Hey folks, sorry I'm going to miss you today. So I'm going to do a video here on copy constructors, copy assignment operators, and destructors. So we were looking at classes that allocate new memory. No, this is the wrong. No, this one's it here, right? So we allocate new memory here. So the problem comes to be when classes use dynamic memory. So we're going to add a new class here. Let's add a new header file for, let's just do assignment. We're going to start with a basic one here. And this my class for assignment is just going to have like the name of the assignment and then the score here. So we'll have a private section and we'll have a public section here. So we'll have an int for max score, we'll have an int for score, and then we'll have a string for the name. Okay, use our namespace, standard, cool. Include string, sure. Include string. All right, now we got that. So we need some sets and gets for these. Now, again, I'm feeling rather lazy, so we'll just go ask the chatbot to do it for us. And that's fine. We can cite our source. Please generate set and get functions for this class. And let's see what we get here. That was our prompt, right? So we'll cite in here, GPT. Please generate set and get functions for this class, and we copy pasted the rest here, but that should be fine. Let's see, it's thinking about it. Here, I'll have copied it all here, might as well. Here, we got to comment all of that. There we go. All right, so there's our prompt, and here we go. Here's sets and gets. I don't want to have to write those myself here. Again, those comments are ridiculous. Like, yes, I know that's the getter, I know that's the setter. They irritate me, so I'm going to take them out here. It's fine if you want to leave them in. It's not going to hurt anything, but sure. All right, so we can get scores. This is a pretty basic class, but then what we want to do is we want to have a gradebook then that has a list of assignments here, right? So let's add a new header file. Here, this will be our let's make this student, right? We'll start with one here. So we'll have student, then so the class for student, our namespace, standard, and we want to include string. This is always so fun. Include string. So class for student then has a private section and has a public section. What student has then is I want a dynamic array of assignments, right? So I want an assignment pointer for my assignments here. So we got to include assignments. Let's go include that. Assignment. Right, I want some dynamic list of assignments that I can go add to. Right, I don't want to have to say, hey, there's always going to be 50 and just allocate 50. This can, essentially add as I need them here. Right, and then we will have a string for name. And really, that's probably it. Right, so then we'll void get name. Nope, set name to a string name. Sure, well, this one's probably fine enough. So this name equals the name. Again, this is our pointer, right, to the instance here. That's why we use this arrow notation again here. And then a string for get name, returns name. Now, get assignments and set assignments is not really something we want to do here, right? Maybe we want to get the list of assignments. That might be something we want to do here. So maybe we have an assignment pointer, get assignments. And maybe that returns the assignment pointer. Sure, we could do that. But we don't really want to set. Really what we want to do is have an add assignment here. Given some assignment. And really, we just need the reference to that assignment. If we wanted a whole copy, we can make a whole copy. Depends on how you want to handle this here. It might be nice to make a copy. It might, if we don't want it to be modified after, we want to make a new copy so that we have access to it. If you just give me the reference and I store that reference, then you can go change that some other time in memory here. We might run into some trouble. All right, and then we also need our constructor, right? We need to initialize this memory here. So we're going to make a constructor for student. Maybe we take the string for name, maybe not. Doesn't super matter too much here. But our constructor then says, hey, let's make assignments is a new assignment array of size what? And maybe we start with 5 or something. We can come up with whatever size we want to have here. So if we know how many we have, we probably should be keeping track of that here, right? So if we have room for 5, I should know which one we have or how many we have here. So the current number of assignments. And then, right, our constructor's job is to give ourselves give our attributes values. We'll set that to 0, and then we'll set name to nothing to start. right? So we set our values for our attributes in our constructor, and we initialize this memory. Right, so this will create and allocate new memory here on the heap. So one of the things we said is when I delete this student object, I want to make sure I go free it up to free up that space. Right? So if we don't free it up, we're going to be leaking some memory here. Let's just crank this up to like 5,000 for a second here, and then go back to our main class, and we'll go do some silly things and make some students. Right? So let's go include student here, and I'll go make some students. I don't know. So for student is 0, student is less than 500, student plus plus, and we'll make a new student. So when we make an instance of student, it allocates that memory here. So we're going to say student. We don't even need the parentheses, right, to create our student. Oh shoot, declared in loop. Maybe I redo. Oh yeah, I can't use that one here. So this is our student. How about student number? There we go. Student number. Goodness, that was a bad copy paste. All right, now I can make a new student here. So as we're going here, when I put this in debug mode, we should see it's going to start allocating more memory and using more memory every time here. All right, so right now our memory usage is at, what is it here? Come on. Is it not cooperating right now? What's it doing? Reset. Can I reset? I don't know. Let's see. Let's continue. Go to the next one. Hey, there we go. Okay, now we see it was moving a little bit here. Being cranky with us. Why? Why is it being so cranky here? All right, reset. Come on. Come on. And continue. There we go. So we see it's jumping up as we go, right? So using so much memory, going on and on and on. Our memory is increasing. Give me 1 second here. All right, and we're back. So we're just memory use is climbing and climbing and climbing as we make more and more of these students here. It's just going to keep on going up and up and up and up. We're not allocating huge amounts of memory at 500, but it's going to go up here. So I want to stop that. So for that to clear, what we need to do is add a destructor that says, what do we do when we're done with the student, when we want to garbage collect it here? So it's the tilde character, which is the shift accent, which is fun, and it goes in front of the name of the class here. That's the destructor here. So what do we do in here? To clear this up, we just want to delete the array of assignments. And then we shouldn't have that memory leak anymore. And then when we run it, we shouldn't be leaking memory anymore because we're taking care of that. When this student object goes out of scope, we'll go and take care of it, and it's going to work out really nice for us here. So we continue and run this one a bunch, and we're not leaking memory. So we're not increasing, because it goes out of scope, gets cleaned up here for us, which is nice. And then if we wanted to specifically make a pointer of that one and delete that one, the destructor would also run, which is fun. So if we go through and say, hey, my student pointer, student equals a new student, right, allocating our own memory here, then we can do whatever we want here, and then we can delete that student pointer here. Student, and if we put a breakpoint at the delete point here and run it, we'll see when we step into our code here that it goes to the destructor. So when you delete, it calls this destructor method here. So we can see that one happening, which is fun. So that's the delete, right? This one's important if we're allocating memory to free it up when we're done. The next thing we need to do is figure out how we make copies of these things here. So if I go and make a student, again, I don't actually want 500 of them here, so we'll just make a student, and before I delete it here, we'll leave that. If I wanted to make another student here, so here I will say student, how about like set name to Eric, so we have one student, and then I'll make another student, student pointer, another student equals a new student. So if I wanted to make a copy of this one here, like if I said, hey, this student is equal to this student, right? My student pointer equals another student pointer. I'm going to have two pointers pointed at the same location. That's not actually going to make a copy of this one here. Right? Or if we were just dealing with our regular objects before we dealt with all the pointer nonsense here, or we can say, hey, my student pointer equals a new student here. Again, this gets a little silly with our pointers here, but we'll say, hey, the dereferenced another student. So the value there equals my dereferenced value of student. Say, hey, change the value to this value here, right? We're not going to get the copy we want to get here because their internal arrays are going to be the same. So if we went and added some assignment, right? So, oh, we never finished the add assignment here, did we, for student? We added in our number of assignments, forgot to do anything here. So first we want to check, hey, if my number of assignments, current number of assignments is less than, right, our max was what, well, let's put that back to something more reasonable here, like 5 here. Or maybe we make this a value here, like int max number of assignments here, and then we can use that. That one will equal 5. These are max number of assignments. So as long as we have room here, again, we haven't figured out the resizing bit, but we can tackle that after. Then I'll say my assignments array, right? That it's a dynamic array. Index of my current number of assignments equals the assignment. So store the value at that location, and then take my current number of assignments plus plus. Technically, you can put that in here. I just think it's ugly. Some people really like that, but that's okay. And we'll add 1 to that assignment. Right? That's it. So now we can go add that assignment in here. So if we go, let's see, we had to get assignments. We're returning that. Yep. Now we want to say, okay, so before we make that copy here, so we'll make the student, we'll say a student.add assignment or arrow add assignment, and we need to give it an assignment here. So let's give it an assignment. Oh, we should make it. Sorry, we should make an assignment first. So assignment, and then assignment dot, I don't know what, set name here to test assignment. We don't really need to do whole lots of interesting things here, so we'll probably leave that. And then we'll give it, here's your assignment. So we'll add the assignment here we just made, just a test assignment, and we get it back out. Then we'll need to make sure we can get that pointer of assignment. So an assignment pointer for assignments is going to equal my student arrow get assignments. Right, so I've got that pointer. Now I can loop through, or really the first one here then. So if I just want to see out my assignments at 0, right, index 0, get name, I'm sorry, assignments.get name here, and then line. We should get back out the test assignment. We made an assignment, added it, we got the assignments back, we got that pointer, we said, hey, give me the first one, get name here. So we should be able to go and get our test assignment. Okay, so we got our test assignment back out. That's working well so far. Now if we wanted to make this other student and make a copy here, right? So say, hey, I want another student to equal this one here. So let's go and let's just move it down here. So, okay, I want another student equals a new student. Well, sure, I don't really want another one though, but what I really want is to be a copy of this student here. Right, and that gets to be a little bit annoying. Maybe how about we say student? We would just assign it student, right? Match a student, and you see right away if we have 2 pointers pointed to the same location, we got issues because they're going to match here. So now if I go do another student and get the assignment, and we want to, this will be assignments. There we go. Assignment pointer is going to be my another student, get assignments, and then grab the first one, get the name back out. Right? It is test assignment. Looks like we have a copy, right? But we don't actually have a copy here because when we change one, we're going to change both of them here. So it's not really going to do what we want it to do with two pointers pointed at the same location, right? It's just not going to work for us. So what we can do is we can add these new things. And I don't know if you saw when we make a student here, student, and you hit your parentheses here, you get 2 options. We get the default constructor and we get this other student reference here. So this is known as the copy constructor. So there's a default copy constructor that says, hey, I want to make a copy of this other student. So we can make a copy of that student here, given my student reference. Right? Remember, a pointer is a reference, so we can give it that student reference here. And it's going to make a copy. Cool. So now let's see. So we did we set name. Now I should be able to do another student. Set name to test, and then we'll print out their name as well. So we'll get their assignment, we'll get their name, another student, get name, and line here. So this is our test student, another student name is this one, and then we'll see out for the student name as well. Let's just do the regular student name and see, did we get a new string value here? So here's my student get name. Right, so student should be Eric. We made a copy, so it should have started as Eric, but then we went to change the new one as test here. Let's see if we get Eric and test. So the student's name is test, another student's name is test. Oh, when we changed one, it changed both, right? We didn't actually get a copy. We have what we call a shallow copy, right? Two items pointed at the same location here. It's not working well for us. Right? Didn't actually do anything. We don't have any code here that says this is what you do. So over in Zybooks, it's got this nice little section here called the rule of three. So really, anytime we're doing a destructor, we also want a copy constructor and a copy assignment operator. How do we make copies when we're dealing with dynamic memory here? Because we get these default ones here, but all it does is copy the value. Remember, the value of a pointer is its memory address. So if we just copy a pointer by value to make a new object, we now have two pointers pointed at the same location. It's not going to work for us here. So, and same idea with this default assignment operator or copy assignment operator. It's not going to work for us. Right, so we need to add these couple functions for it in our code, which is nice, right? The destructor, the copy constructor, and the assignment operator, copy assignment operator. We're going to add them all in here. So we're going to go over to our student class. We're going to add those in. So then our student constructor, that takes a constant student reference, I don't know, student or something. What do we do for this one? Well, if I want to become a copy of this one, I need to make my new assignments, right? I do all my same things here, but then I need to go through and copy off the student ones here from the other student. So for, this is going to be, we need the assignment. So assignments to copy, right, is going to be my pointer. So an assignment pointer of assignments to copy is going to be that student reference we were given dot assignments pointer, right? Assignment, it'd be nice if I could spell these things right here. Assignment. So an assignment pointer, we're going to call it assignments to copy, will equal this one. So we're going to start looping through their assignments here, right? So then I can say for index is 0, index is less than my max number of assignments, index plus plus, and then we'll take my array and assign it the value from their array, right? So my assignments at the index will equal the assignments to copy at the index. Right? Go through, take theirs, copy it to mine, take theirs, copy it to mine, take theirs, copy it to mine, take theirs, copy it to mine. Right? So this is how I can make a copy of those values here. Now I probably also want the same current number of assignments as well, right? So this will be my student dot current number of assignments. So you pass me the student, I'll copy its current number of assignments. You pass me the name, and I'll take its name. Right? So we can go and get the copy of these out here now. Let's see. So now it should. Oh, it didn't do it when we. It might be because we're using a pointer. Hang on. It gets really obnoxious with these here. No, student. So that's going to be the dereferenced value of student, right? Should be another student. And if that's not a pointer, it's all just dot notation here. Dot. Is this going to do it for us? Let's try it. Gets really obnoxious here. There we go. Okay, so using the non-pointer notation worked that way. I think if we want to use the pointer notation, I can go back and say, hey, this is a student pointer. We would use the new notation equals a new student given the student to copy here. Right? Then I can use my arrow notation again here, and this should work out for us here. And we want to get in the habit of using pointers. It's a good habit, good practice to get into. I need the dereferenced value of this student here, right? There we go. Let's try that again. And we get Eric and test. So now we have an actual copy here with this because we made the copy constructor, right? So we're going to go through with the copy constructor in our project. We have to go through and do it this way. Again, this one's not variable at this point. It can be. You can just go off your current number of assignments, right, and size it to its current size, right? We have to just track some other values. And then the last one we want to do here is the copy assignment operator. So when we use that equal sign, when we say, hey, this one equals this one, we don't want to make that shallow copy and to say, hey, all my values are going to match. We want to go through and make a deep copy that says, okay, make a new instance of dynamic memory here, right? Allocate some new dynamic memory and copy them over to the new one here. So the syntax is a little funny. It returns a reference to an object given a constant reference to the other object. So it's the reference to a student for operator equals given a constant student reference student. What does it not like here? The same name of its class. Did I screw it up here? Oh, that's backwards. There we go. Student reference there. Using the operator equals given a constant other student reference. So the only thing we want to be careful with these ones is that we're not trying to copy ourselves. Right? We want to make sure that the student you gave me is not the current one here. So most of the time when you do these here, there's a quick little check we're going to do here that says, hey, I am not that one. Oh, it's not in the rule of three. Let's go back to the copy assignment operator. I'll just go shamelessly copy paste their code here. So we go and check to see, hey, if we're not theirs, right? If this is not the object to copy here, then we want to go through and do that, right? So if, or this is a pointer, does not equal the student. And then we need the reference here, right? The object to copy reference. So if this pointer doesn't match what this value is, right? Where is this memory reference? Because my pointer, all the value it is a memory reference. So if that memory reference doesn't match this memory reference, then we want to go ahead and copy, right? Otherwise it gets weird trying to make a copy of a copy and funky stuff is going to happen. And what's interesting with this one is when we're done, we're going to return a student reference, right? Which really is just your pointer, right? The dereferenced pointer here. So we're going to go and change our current value. So if we're going to make a copy, we first need to go and delete our assignments, right? Because we were a student, or we were an instance of student. We had already run our constructor, right? Because this one existed. So I need to go delete this memory, free it up here. Then I can go take my number of assignments, current number of assignments is equal to the student.current number of assignments. We can take my name is the student.name. Then we need to go through and loop and do the same thing again here, right? So make our assignments to copy. So, but before we copy them, right, we need to go allocate that new memory. Right? We deleted this one here, so we need to go make new memory for us here because we wanted to free what used to be there and get rid of anything that was there before. So then my assignments equals a new assignment array, size of my max number of assignments. Right. Then I can go through, copy them over here. So this way I can use my assignment operator. So we'll go back to our little code here. So instead of it equals a new student using the constructor, now I can say, hey, I have one more student. So a student pointer third student equals a new student. We'll just make an empty one, and then I can say, or I think we can even assign it here. So third student equals another student, right? Is that not, I think that'll do the assignment operator. Let's try it and see. Let's see if this goes into our assignment operator code. Let's run into debug mode and step in. Did not step into. Shoot. Okay, so that gave us the same. Is that the same pointer then? Yeah, we wanted the dereferenced value of this one. Oh shoot, the reference of this one. It's really annoying. What is the? Yeah, just equals. Okay. Copy using the copy assignment operator. When we start using pointers, it gets confused sometimes here. So let's skip that then. We'll say, hey, student equals, and this will be the dereferenced value of another student. That one ought to do it. Let's try that. So we step into, now we get our, well, here's a copy constructor. Let's see, let's keep going. Copying over assignments, come on. And step into, oh, this one ran the copy constructor. That's interesting. It didn't run the copy assignment. Oh, because we didn't make it first. So if we make it first, student, then third student equals another student. Let's try that one. The order in which we do this is annoying. Oops, student. Oh, we never returned this. There we go. So that's weird. It didn't even compile. I think because it crashed here. So then we're going to return the dereference this. I mentioned that and I forgot to do it. So return the dereference this. Now when we step into our code here, now we get the operator equals code. Because we're saying, hey, this one that already exists equals this, oh, that's the wrong button, equals this new value. It gets a little wonky. It's a little weird thinking about which one runs what. But it's okay, it just takes a little bit of time. We'll get through it, but a student that exists, we want to give it a new value, right? Versus making a new instance kind of inline here. That's all. So that's lots of fun. We're going to practice with these. Don't forget, we want to do the dynamic sizing here. So when we're looking at changing it here, right? How do we add more room to it? Dynamically allocating changing the size of our dynamically allocated array. That's what we want to work on for the project. So as we go through, let me pull up Canvas again here. And look at that, because we make our trainer, and the trainer has that dynamic list of fighting pets. Pull up the assignment. So we're not going to automatically go and make more room, right? But we want to be able to add more storage when we want to. Again, probably related to some sort of leveling up, but again, that gets to be more complex than we really need to at this point here. So when we need to make more room, then we just need to increase our size here, right? And then we do the copy of all of those into the previous array, making sure we into the new array, making sure we delete the previous one once we've copied out of it here, right? And there's some steps you can follow through. So if you have any questions, thoughts, concerns, let me know. Sorry I wasn't able to see you today, but I'll see you on Tuesday, and we'll have a lot of fun. Take care, folks.